oh my God, I see the way you shine. Take your hand, my dear, and place them both in mine. You know you stopped me dead while I was passing by. And now I beg to see you dance just one more time. Ooh, I see you every time. And oh my, I like your style. You make me wanna cry. And now I beg to see you dance just one more time.
I just had to let you know you're mine. Hands on your body, I don't wanna waste no time. Feels like forever, even if forever's tonight. Just lay with me, waste this night away with me. You're mine. I can look away, I just gotta say.
At the end of this video, you should be able to answer all of these questions.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd FIRDAUS bin Abdul SAMAT from Bmcg S2. So I will discuss about the statement. So let's start. The statement says that a road of length is equal to 50 cm. This is a road. The orange color is a road of length 50 cm. Its immerse in steam until its temperature is 100 degrees Celsius up. So from the center, you can get the initial condition is 100 degrees Celsius, which is its initial temperature. At time t0 minutes, the electrical surface is insulated at its two ends are abandoned in ice at 0 degrees Celsius. The sentence means that there is two ice cubes. One, two is placed at the both end of the road like this. This is a road and this is ice cube. First end and second end of the road. From this we can obtain the boundaries condition, which is 0 degrees Celsius, and its time boundary is at x is equal to 0 and x is equal to 50. Next, at any time t, the temperature U at the point x on the bar satisfy the heat condition equation. This is the equation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Very good evening. My name is FAHMI. So today I will explain to you about part D using numerical method. So by using the finite difference approximation formula, we get this formula. So using this formula, we can get the values of the temperature, which is U. So to get the values of the temperature U, you can just substitute the values of X and T one by one into the formula. So once you have all the values for the temperature, you can plot the graph, this one. But from here, you can see that it's not very accurate. This is because the interval that we use is too big, which is 12.5 centimeters for X and 15 minutes for T. So to get a more accurate data, we need to use a smaller interval, like this, 1 centimeter for X and 1 minute for T. So now just substitute the values of x and t to this formula to get the values of the new temperature U. So once you have the data, you can plot a new graph, which is this one. So from here, you can observe the data. This is time t, this is its length x, and this is its temperature. That's it. Thank you.
Hi, I'm Hao, here to explain about question C of this assignment. So in this question, we need to find the analytical solution for the heat equation. So we'll get that the temperature U is equal to this equation. And from the equation, we found that for even number of n, U is equal to 0 because this term over here will be equal to 0. And for all number of n, U is equal to this equation over here. And this will be used to find the solution. So to find the solution, we need to get the value of each of the point to make a plot. To do so, we need to substitute the values of x and t and also n into the equation to find the values. So to find the values, we use a table over here for each individual point, and we found that U is only valid when n equals to 1, because all the other terms will be 0 over here. So for a better solution, we decided to use a smaller intervals to find the solution. So over here, we're using only n equals to 1, and the equation is given by this equation over here to find the U. So we need to only substitute the values for x and t. So after substituting the value into the equation, for each of these points, we can get this data of table, and then using the data in the table, we can make a plot, which is as shown as below. So in this plot, there are three axes here, which is temperature, length, and also time. So for the legend over here, the deeper color is for higher temperature, and the lighter color is for lower temperature. So when the time t is equal to 0, all part of the rod is equal to 100 degrees Celsius, except for the very end point is equal to 0 Celsius because of the initial condition and also the boundary condition. And when the time moves, the temperature will be dropped at different point of x in the rod. So after 30 minutes, we get the temperature is the curve at the edge here. So the temperature at both ends is still 0, and at the middle here is higher and about 20 something. And this is the result for the analytical solution.
Now we will go through to the next part. For this part, we were using small h and k. For this slide, there are two tables represented, the numerical method and analytical method. Those table and graph, we can see that analytical method is more accurate. for the numerical method, we can see from the graph is not smooth. There are some positive and negative points. We also can see that the graph is not consistent. The temperature also do not in the range between 0 until 100 degrees Celsius. So when the maximum is high, the minimum is lower until 10 power of 53. But for the analytical method, the exact solution analytical to temperature change is very smooth. And both from the graph are balanced. Then, when we go through to the table of numerical method, the point, mostly the point is using 3 points, so there will be an error.